Hello. Great to have you with us today. The problem that we're going to be looking at here is going to generally talk about using chi-squares test wisely, right? When do we use, when do we not use, what do we need to know? And the setup is that we have an article from a newspaper with a table, right? And we want to analyze this table using the chi-square test. However, without any additional information about how the data were collected, it isn't possible to know which chi-square test is appropriate. This is a very, very, very important concept. Right? Now we need to know about how our data was collected in order to be able to use an appropriate inference technique for statistics. Okay, so for the first part, how do we know that a goodness of fit test is not appropriate for analyzing these data? Well, think of what a goodness of fit test represents and why this data would not fit that well. Come up with your answer, press pause, right? Then unpause and check back again. Well, a chi-squared goodness of fit will be used when you're analyzing the distribution of one variable in one population. For example, we had the problem about analyzing the car color, our variable, in the Oro Valley, our population, right? That was one of the very first examples that we discussed. Here, if we look at this, we could either be talking about those that use online social networks or those that do not use online social networks. But we cannot do a chi-squared goodness of fit when we're looking at both of them together. And the distribution of the chi-squared goodness of fit is to some standard. Okay? So, B, think about it, pause the video, come up with your solution, unpause the video, check your work. For B, if we're going to be collecting the data for a test for homogeneity, right, to determine if the two distributions of use and not use of social networks are the same, right, we could either take 6 independent random samples, one from each age category, right, so 18 to 24, 25 to 34, right, third category, fourth category, fifth category, sixth category, and ask them about their social networks. Do you or do you not use social networks online, right? Or we could take 2 independent random samples, one from each social network use or not use. So take a random sample from those that use, take a random sample from those that do not use, and we'll ask each sample member their age. Hey, how old are you? Record those ages. How old are you? Record those ages. Compile the data. Right, so 2 different ways we could collect the data for a test for homogeneity. Right, think about C. How would you collect it for a test for independence? And come back after pausing the video and check your work. Okay, so for C, describe how the data could have been collected for a test for independence. Excuse me. Well, we could take 1 random sample from the population of interest, ask every member their age and their online social network use, right? So that we would say, hey, here is a thing, and amongst the questions, what is your age? Amongst the questions, do you use online social networks? Collect that data. That is generally the easiest option for obtaining data, right? Because you don't have to pre-sort the groups. We don't have to know their social media use ahead of time. We don't have to know their age ahead of time. We can simply go through and say, hey, let's get this information and then look to see if there is an association. This is the exact same approach that we talked about at the beginning of the year when we drew graphs. However, this method is a little bit more rigorous because of the inference techniques that we use. Additionally, without knowing how our data was collected, we can't use any of our inference methods, right? So, hey, yeah, like, no good for goodness of fit, But homogeneity versus independence, if we don't know how this data was collected, we can't just do a test, right, and have valid pieces. Okay, so in general, how can you tell the difference between independence and homogeneity? Well, think about it and check your answer. Okay, so in general, how can you tell the difference between independence and homogeneity? Well, with independence, both in this case, or all, right, all sets of totals, your rows, your columns, right, are randomly collected. So in other words, right, the age groups aren't predetermined. We randomly gather all the data and we get some totals. The online social media use is not predetermined, right? From our one sample of our population, we then get this information. So we have not pre-described or pre-sorted our age groups, and we have not pre-sorted our social media use. So when all of that is random, right, your rows and your columns, that's independence. However, if the researcher, right, whoever's collecting the information, does choose one set of totals, right, a marginal distribution, then we're looking at homogeneity, right? So as this example about the 6 independent random samples versus 2 independent random samples, if we said, hey, let us consider those that use social media, those that do not use online social networks, and ask each of those groups. Well, we determined the 2 groups to select from. We had to go in there and say, hey, let me ask 386 that use social media. Let me ask 698 that do not use social media. Okay? Or, hey, here is a group of 183 of this age range. Let's ask them the questions. Here's another group of 221 of this age range. Let's ask them the questions. So when we are selecting a particular set of groups to ask, that's homogeneity. When we are selecting just one random sample from a total population and gathering the data and looking to see if there is a relationship there, then that is independence. Okay. The best practice for this is practice. You should look to the sample problems that we provide and work through those. Okay. If you have any questions, make sure that you ask them, think through whatever needs clarifying. Have a great one.